Welcome to Train Signal and the lesson Securing DNS with DNSSEC. We're exploring again advanced features of Windows Server 2012 technologies. DNS is no exception. DNS has received a facelift in the form of DNS security extensions, DNSSEC. So in this section we're going to explore kind of a quick review of basic functionality of DNS. We want to make sure that we cover our bases there and make sure that you're aware of the existing functionality of DNS, again, to make sure we've got our terms in order. And then we'll explore beyond that into the new exciting security functionality that Microsoft wants us to take advantage of. So first, a quick DNS basic functionality review. I'm going to go ahead and flip over to my server so I can show you some of just the basic outline of what DNS is and how it behaves. Of course, in general, you're aware that DNS is a name resolution server. I've got computers that want to be able to find computers in the network by their IP address, but they don't know the IP address, so they go call the server, and the server says, that computer with that name, yeah, here's the IP address for that. So that's our main goal in DNS functionality overall, resolving names to IP addresses. Now, of course, later on we'll talk about Active Directory. We'll see that there's actually yet another layer of useful DNS functionality that gets deployed there. But for the time being, this will do for our purposes. So, name resolution is our goal. We're going to accomplish that by configuring a DNS server with what are referred to as zones. A zone is a database of a sort. It's a collection of resource records of information that describes computers, their IP addresses, their names, these sorts of things. Gathers that all together into a collection that we can query from across the network. That's our main goal. So let's take a look at how that's basically deployed. So here's the DNS Manager console. We're here on Server 1. We're going to introduce basic functionality primarily by way of review. Remember, this is the Advanced Services course. It's presumed that you've got a basic grounding in DNS functionality so that we can then build on top of that. If you don't, that's a great reason to go take Train Signal's Installing Windows Server 2012 course. We cover that in detail there. But here we go into basic functionality. Our basic functionality centers around, the idea of zones. A zone is a database of information. I'm going to explore here forward lookup zones. I've already got a zone for my Active Directory domain, globalmantics.local. Globalmantics has got an AD infrastructure, and we can see some of that represented here. If I needed to create another zone, I've got a division of my company that's launching a project. They want to be able to have their own separate domain name environment for it. I can accomplish that. I'm going to create a new forward lookup zone, identifying it by having a primary or secondary nature most of the time, some stub zones, but mostly primary and secondary. Primary, writable copy of the zone. Secondary, backup copy. Again, this should be familiar to those of you that have a background in this. I'm going to make this AD integrated for the purposes of simplicity. Where do I want the data to be replicated? The whole domain is fine, globalmantics.local. What's the name of my new zone? Demo zone. Local is a fine choice if I don't intend for it to be directly resolvable from the internet, and I don't. Do I want to allow secure dynamic updates? Sure, we'll make sure that only members of my domain are able to update this data. And there's a zone. So zone creation is pretty straightforward. What if that zone is not meant to be managed here at this server, but instead on an entirely different server altogether? I get my demo zone set up here on my corporate DNS server, and the people running the project say, no. You see, we got our own DNS servers. We want to be able to run this project from over there. Can we do that? Well, sure. Let me delete the zone that I created here. And I'll create this not as a local zone hosted at this server, but as what's referred to as a delegation. We're going to make this a child domain underneath globalmantics.local. I'm going to create a new delegation underneath that level. A delegation is a way of saying, I'm not responsible for this part of the DNS namespace here. That's handled way over there. Go talk to them. Because, again, that other project team, they've got their own DNS servers. I want to be able to hand off responsibility to them. Demozone.globalmantics.local. This is a child domain underneath my existing DNS domain environment. It wants to know which DNS server is handling that. Well, that project team has set up a server way over there. It's called New York City Server 2. I can ask the DNS console here to resolve that for me and find out what the IP address is. Otherwise, I could have typed it myself alternatively. And it's got a warning here, not a serious concern, but one worth taking a quick look at. It does say, the server with this IP address is not authoritative for this required zone. In other words, it's already looked over at server 2 and said, hey, I don't see a demozone.globalmantics domain over there. That's okay. We can create that after the fact. We don't necessarily need to do it in the right order. This is just warning us saying, hey, I don't see what you're looking for over there. So we are going to use that. There it is. We can see the delegation has taken place because of the grayed out folder here that reflects the presence of the demo zone. Neat. All right. Other important basic functionality of DNS servers. I can have DNS servers forward information to other DNS servers. If I've got a request that hits my DNS server, one of my local clients calls my DNS server, says, hey, I'm trying to resolve this fully qualified domain name. I'm trying to find www.someothercompany.com. Do you know where it is? My DNS server says, I've never been there before. But you know what I'll do, says our DNS server. I can forward that to somebody who can help. If we right-click the DNS server, pull up its properties, the Forwarders tab identifies a list of other DNS servers that this server can use to resolve queries. I can edit my forwarders list, and maybe I've got an IP address from my ISP. I've got a ISP provided DNS server located at 17.202.18.4. Now, any requests that come my way that I don't know how to handle, I'm going to send it there. It's trying to resolve that IP address. It won't get there because this computer isn't actually, in fact, provided with internet connectivity. I'm using a virtual machine. But that being said, worth also pointing out, by the way, what if there aren't any forwarders? Then what do we do? Well, actually, every DNS server has kind of an implicit set of forwarders referred to as the root hints. And there they are. 13 IP addresses representing what once were 13 physical servers representing the logical top of the DNS architecture. Those 13 servers have been replaced by a process called anycasting, so it's many, many more servers, but the same concept remains. A list of server IP addresses that I can send requests to so as to be able to resolve names of theoretically anything on the internet, assuming I've got access to those IP addresses. Okay, so we're good there. A couple other things I want to show while we're in the neighborhood. Some advanced configuration settings. One interesting bullet point that appears in the exam requirements, for those of you that are heading towards Microsoft certification, does invite the exam taker to be aware of how to configure netmask ordering. And there it is. You'll notice that it's on by default. Netmask ordering is a way of saying that if there's more than one IP address resolved for a given name, that name that we want to resolve, when we go to resolve it, we want to get the IP address that's in the same subnet as the requester if we can, if there is one. If there's not, then it doesn't matter as much. We don't know exactly how far away those other subnets might be, but that it will attempt deliberately to reorder multiple records that match the name that a user is asking for, so as to supply the ones that are in the user's subnet first. The user then will preferentially be connecting to resources that are nearby them, rather than connecting to perhaps identical resources but on the other side of the planet. Neat idea. Also in this neighborhood, monitoring. That's another exam topic while we're in the neighborhood. I can do basic monitoring here, querying my DNS server to see if it seems to respond. I can go further with the event logging area here, turning on various kinds of logging levels, and I can go one step deeper still with what's called debug level logging. Turning on extensive logging of very, very detailed behavior inside of my DNS server. Okay, so there's basic DNS functionality. Let's start shifting into some relatively newer technology. There's something referred to as the Global Names Zone. Global Names Resolution is designed to be yet another attempt to continue to replace WINS. Some of you may have a background in Microsoft technologies and know about the WINS server feature, Windows Internet Name Server. This was back when Internet was a synonym for LAN and didn't mean the Internet with a capital I. A local LAN was called an Internet with a lowercase I. Windows Internet Name Server was a NetBIOS name resolution server. It's a totally different type of computer name that Microsoft was fond of for a number of years. Microsoft has been trying ever since about Windows 2000 to kill WINS. They've had a hard time doing it. There's been a lot of applications that have a need to resolve NetBIOS names, and as a result, WINS has kind of stuck around. So the global names feature of DNS is yet another attempt to provide an alternative to WINS to allow us to eventually phase WINS out of an IT environment if we can avoid it. So how do we do it? A couple of things have to happen. We need a new zone whose name, somewhat surprisingly, is just global names. I'm going to make it a primary AD integrated. That'll be fine. Global names is the required name of this interesting zone. It's not global names dot something. It is merely global names. And what it's meant to be a container for is a list of what are called alias records. Alias records are also known as canonical name, CNAME records, and provide a mapping between one name and some other name. Maybe I've got a Windows NT4 computer still lingering in my network. It's been there forever. People know how to use it. People only are able to get to it through WINS. And that computer is called, let's see, what sort of an application is it? It's a payroll application. Server is just known as payroll. But in our real-world environment, that particular payroll server is now being upgraded to Windows Server 2012. We're not going to attempt to refer to it by its NetBIOS style single label name anymore. That's now going to be a server called payroll server 6.globalmantics.local. So that's payroll server 6.globalmantics.local, and that is the FQDN, fully qualified domain name, is the technical term for a DNS record to be looked up, a name to be translated into an IP address at some point. So now, where my clients used to try to connect to a server whose name was payroll, if they hit this DNS server is able to say, payroll, yes, you mean prs6.globalmantics.local. Client says, okay, yeah, whatever, just give me the IP address. It's a neat trick. WINS was very good at resolving names to IP addresses, but only for these what are called single label names, names where there's just one piece of the name, and that was all there was to it. Maximum of 15 characters historically. So, how do I get clients to this global names zone so that they can resolve this single label name to an FQDN, turn the FQDN into an IP address, and connect to the payroll server? Well, we need to tell DNS that it's okay to do the global names thing. And that's done from the command prompt, interestingly. We're going to use a command line tool called DNSCMD. So let me pull up in my start menu. There we are on the start screen. So this is where we're going to launch CMD, the CMD utility from. DNSCMD is a command prompt utility. So to get to the command prompt, I've gone to the start screen. Get used to the start screen, and we're going to see it as its the replacement for the classic start menu. I can even type while the start screen is up and search in it, just like I did in the start menu. Once you get used to it, it's reasonably comfortable, but it's a little uncomfortable for those of us that are unfamiliar with this as a server administration tool. Anyway, DNSCMD is the tool that we care about, which does a whole host of things. We're going to use it specifically for our work in enabling the global names zone functionality, but there's lots of other things that I can do with it. I can do basic zone administration, creating and deleting zones. I can gather information about what the DNS server is doing. A lot of other sophisticated changes lie here under the DNSCMD/config context. So that's where we're going to go. First, I am actually going to stop a second and look at a couple of things under DNSCMD/info. Before I actually do the global names resolution and move forward into that section, let me show you what we can do with a couple of other security features that are, importantly, test items or potential test items in the list of topics that Microsoft says might be represented on the exam affiliated with this course. That being said, let me do a DNSCMD/info, and I want to focus on a couple of things before we do our global names. One is called socket pool size. A socket pool is a pool of port numbers that a DNS server can use when communicating with other DNS servers. In general, DNS uses a fairly predictable port number to do its communication with other DNS devices in your network. The challenge with that is that the bad guys know those ports. And they're able to build software that intelligently listens for traffic on those ports and is able to perhaps intercept traffic or try to mangle that traffic in some way to cause havoc. So what do you do? Well, what you do is you turn on socket pooling, where instead of using just one socket, a socket is a combination of an IP address with a protocol, TCP or UDP usually, and a choice of a port number, and it randomizes the port number within a certain range of possible values. So we're seeing that here. We can see we have a socket pool size of 2500. This is a default configuration. This is something that is on by default at a certain level. If I want to adjust that socket pool size, maybe the CIO comes by my desk and says, hey, I've heard about concerns with people snooping on DNS traffic. Can we crank up our socket pool size above the default of 2500? I want to make sure we're absolutely secure. Sure thing, boss. Let me do a configuration on that, setting the socket pool size to some higher value, maybe 4000. There we go. So we've configured our socket pool size. We now have a higher number of ports available for DNS to do its work. Another representative example is something called cache locking. Let me do a /info again. Something called the cache lock %. Cache locking % by default is 100. What does that mean? Cache locking is about making sure that we're able to guard against an interesting DNS attack that targets the caching functionality. DS, as you're probably aware, if you ask it to resolve something for you, it will resolve that name to an IP address and cache that information for a while. It will remember what you asked so that somebody else can retrieve that same information without another retrieval from wherever that data came from, some other DNS server out there in the internet. We can identify a potential attack in which somebody attempts to update that caching data to be able to change what's in the cache. And we can actually adjust the cache locking %, the percentage of the available time to live before you're able to adjust a cache, and adjust that number up or down. Here it's at 100, but if I wanted to make it 50%, I can again, following the same pattern we did when configuring socket pool size, I can configure cache locking %. Let's make it 75% by way of example. Did it work? It sure did. So those settings, very adjustable, nice ways to be able to tweak the security settings associated with DNS. Now let me get to the main event. I wanted to illustrate the global names zone functionality. That's another DNSCMD query. We're going to do it this way, DNSCMD. We need to name the server that we're applying this to, because we could turn it on one of a variety of servers. In this case, it's going to be on New York City server 1. I want to configure the feature known as Enable Global Names Support. That's a long one. Note the doubled S in the middle there, Global Names Support. And I want to turn it on, which is 1. All right, let's shift gears into some somewhat newer technology. Our next big area of exploration is DNSSEC, DNS security. Let's imagine that you're sitting at your desk when you get a visit from the Chief Information Officer of your company. CIO comes by and says, hey, I've been hearing scary things about security in name resolution. I've heard that there are ways to attack a DNS server to be able to exploit it and gather information and redirect requests that are supposed to come to our servers and send them to hackers' servers. I want you to do what you can to make sure that our servers are secure from that sort of attack. Okay, so you do some homework and you discover that Microsoft has made available something called DNSSEC, DNS security. So what we're going to do is we're going to engage that technology to do something called zone signing. Zone signing is an idea centered around what's called cryptography, and specifically something called private public key, or PKI, public key infrastructure, public-private key cryptography. It's a system of using what are referred to as digital keys. These are basically large numbers, used to be able to scramble data in such a way that only the authorized parties can unscramble it. And you can do a number of things with it. One thing you can do is scramble data so that only the good guys can read it. That's nice. The other thing you can do with this public-private key scheme is digital signatures. You can apply a digital variation to a file in such a way that it clearly could have only come from one source. In that way, we're able to validate that data comes from a trustworthy location. those keys need to originate somewhere. It needs to be some starting point. And in the DNSSEC world, it starts with something referred to as a trust anchor. Trust anchors are a starting point for what might well be a series of validations that take place in DNS. I trust the DNS server, therefore I trust when the DNS server says that the zone is secure. And the zone has a key that it uses to sign individual records that lie inside of that zone, and those things are digitally signed. I trust them because I trust the zone. I trust the zone because I trust the server. So there's this chain of trust relationships that hang together. So what we're going to do here is we're going to configure zone signing. We're going to sign the zone, and then we're going to ensure that the trust anchors that describe that zone are going to be available to anybody who needs access to them. So I'm going to actually go ahead and switch over to the server environment to show that to you. Let me jump back over to server 1. So here I am back on server 1, and I want to be able to configure zone signing. That is a simple to moderately difficult process depending upon how you approach it. The basic starting point is pretty straightforward. I'm going to go right-click my zone, go to DNSSEC, and sign the zone. When I decide to configure zone signing, we start into a wizard that walks us through that process. And I've got three main options to start with. I can just use default settings. If I use defaults, the wizard picks a number of very technical, detailed settings, most of which are probably fine for practical purposes, and signs the zone. That's pretty easy. You can't get much simpler than that. I'm going to undo that process to show you a different approach. I'm going to unsign the zone. It is just as easy as that to reverse this process. So that zone is now unsigned. Let me re-sign it. There's my defaults. I have a middle option. If there's already a zone out there that's signed the way that I like, I can just say, let's sign this zone the way that that zone is signed. Save myself some effort. That's nice. I'm going to walk you through the custom zone signing parameters to be able to give you a thorough grounding in what's happening behind the scenes here. So step 1 is the selection of something called a key master. The key master is the starting point for creating these keys. Keys have a matched set relationship. There are two keys that are generated, a so-called public key and a private key, and they're a matched pair. Something that is digitally signed with one of those two keys can be verified using the other. Something is signed with a private key. If I can unscramble it with the public key, then I know for sure that it came from somebody with the private key. If I scramble something with the public key, the only way to unscramble it is with the private key. So the key master is the originator of these keys. So I can pick any DNS server to be my key master as long as it is a primary. In this case, this DNS server is a fine choice. I'll let it be the key master. I'll invite you to keep the Ghostbusters jokes to yourself. All right, next question, key signing key. We want to be able to start the process of creating this chain reaction of keys that are used to secure DNS. The starting point is something called a key signing key. It digitally signs other keys that are used to be able to secure other components of my zone. So we get a choice of one of a series of KSKs that I can create, key signing keys. There's one here left over from the default configuration a moment ago. Let me throw that away and build it from scratch. We can, for most DNS implementations, satisfy ourselves with just one key signing key. That's usually fine. We might consider more than one if I've got different client computers that are able to only speak different kinds of encryption. I might do that if I'm merging two different organizations that have different KSKs within their organization. I'm trying to consolidate this down to a single organization. That might be a reasonable thing to do. So in any of those reasons, I might choose to have multiple KSKs. But in this case, just one's probably fine. We can either use keys if we already have some, or we can generate new ones. I'll do that. We get a choice of a cryptographic algorithm. Algorithms for cryptography are ways of generating keys, and there's a number of different approaches. One whose name I want to draw your attention to is this guy. We're going to talk in a minute about something called DNSSEC, a way to be able to securely identify that there is no record of the type that I'm looking for. If I'm going to be doing RSA, SHA-1 type cryptographic signing, I need to choose this one and not this one if I want to use DNSSEC. Of course, you can probably guess that by the fact that it says NSEC3 in it. I'll explain NSEC3 in a bit. For the time being, I'm going to leave it at the default of RSA SHA 256. We're using a 2048-bit key. The longer the key is, the more secure the encryption is. The shorter the key is, the faster the encryption goes. So it's a trade-off between security and efficiency. The faster I want it to go, the fewer bits of encryption I need to do, but that makes it less secure. The more secure I want it to be, the more bits it needs to be, but that increases the time required to get that work done. We choose a key storage provider, a place to store keys. Microsoft has a built-in one, that's fine. We get to specify how long we want these signatures to be valid for. After a certain period of time, a certificate, a pair of keys, can go invalid. I can generate new ones. It's a security technique to make sure that everything stays secure. So how often do I want that key rollover to take place? I can specify that below. And we've got ourselves a KSK, a key signing key. The next phase is a zone signing key. The zone signing key is going to sign zone data. That key will in turn be signed by the key signing key, for those that are curious. And once again, I get to pick my cryptography data. And once again, that works almost exactly like the prior example. We choose an algorithm, we choose a number of bits. Note that the default number of bits for the ZSK is half that of the KSK. The KSK needs to be much more secure. We're going to keep it for a longer period of time. It secures a greater quantity of data. The ZSK is used for just a particular zone. Different zones may have different ZSKs, and they may turn over more frequently. We can see that these keys will roll over every 3 months, as opposed to the much longer period of time we saw, a couple of years, for the KSK. With that done, I can move on and configure NSEC. The general idea of DNSSEC is I want to secure the information that identifies the existence of DNS data. Somebody calls a DNS server, says, "Hi, I need a resolution on this name and IP address." And the response comes back. What we want to be able to do is say, yes, I can see that that is a secure response. Well, part of that secure response involves encoding information about the actual data itself. But what if there is no data? What if there is no record of that sort? I call a particular DNS server and say, "Hi, I'm looking for a server called payroll server number 7. That server says, server 7. Yeah, we don't have one of those. I don't have any raw data to encrypt to be able to supply an encrypted version of that response. So what do we do now? What we do now is we do something called a secure denial of existence, an authenticated denial of existence. We have a way to be able to say, no, it's not there, in a way that is as secure as saying, yes, here's your answer. NSEC, or the next secure algorithm, is what provides that ability. And here we can see support for classic NSEC, or something newer called NSEC3. We like NSEC3. NSEC3 makes us happy. The reason why is it avoids the danger of something called zone walking. NSEC creates a logical chain linking together all of the records that do exist to be able to have something to respond with to say, yep, what you're looking for doesn't exist. A clever, determined hacker could issue a series of requests trying to get NSEC responses, and by stitching together the patterns of what's coming back from those responses, might be able to make good guesses about what is in our DNS database by looking at the responses that describe what's not. It's a sneaky sort of an attack called zone walking. NSEC3 helps dodge it. So in general, we'll prefer NSEC3. Trust anchors is next. Trust anchors, again, is identifying where's the starting point. Where's the information that we want to make available for somebody who wants to learn about the security that we've applied to our DNS environment. In general, we will enable distribution of trust anchors. If this DNS server is an Active Directory integrated primary, I can check that box and automatically deploy it through my whole forest. If I haven't, I need to take some extra steps. What I'm going to do is I'm going to illustrate that a couple ways. I'm going to deliberately turn off the option to distribute the trust anchors immediately. I want to show you how to do that in a more manual fashion if necessary. Additional advanced parameters: how often do we make changes to the environment? How often do we roll over some of our keys to be able to replace them with newer ones? In general, we'll leave those settings alone for practical purposes. All right, and we've reached the end of the zone signing wizard. We've signed the zone, and we're in business. How can you tell that something changed? You can right-click the zone and pull up DNSSEC properties, you can see all the details that we just got done configuring. It is here that I can turn on distribution of trust anchors if I hadn't done so before. So that's a good idea. We'll do that. Lets me know that we've made change to DNSSEC. The primary impact of which, let me say no for just a moment, is that initially, without having turned on that trust anchor distribution, there's nothing here in this area referred to as trust points. Trust points is a zone of a sort, something that acts a little bit like a zone. It acts like a zone called globalmantics.local.trustpoints, which is kind of interesting. You have to create that zone. It's kind of there implicitly. And by standard, a request for this DNS server to ask it for information about DNSSEC security will look for that container. If it finds it, it expects to find information in it. At the moment, there's nothing in there. Why not? Because I elected not to distribute my trust anchors. So let me go back to my DNSSEC properties. I'm going to right-click my zone, get down to DNSSEC, over and down to properties. I'm going to elect to distribute trust anchors for this zone. Yes, we've made those changes. We'll say yes this time. And now, when I refresh trust points, I'm going to throw an F5 at it, I see a globalmantics.local domain hierarchy underneath trust points. If you read it backwards, it's globalmantics.local.trustpoints. And inside of it, I've got two records called DNS key records. DNS key records have the job of being, again, that starting point. Let me browse into one for illustration purposes. We can see that this is a secure entry point. This is a starting point for learning about the security configuration of this DNS server. It has a public key, and that meaningless gibberish is a thumbprint of that public key. It's a snapshot of what the public key looks like for encrypting and decrypting. A client computer, another DNS server, could retrieve that data to be able to begin authenticating communications with this DNS server. Request hits this DNS server, and the server says, yes, this server name goes with this IP address. The client thinks to himself, well, how do I know that this is coming from a real DNS server who I trust? And it's going to use this DNS key, public key, to be able to validate the communication that came from that server. It's a neat trick. Okay, so there is the automated trust anchor distribution. Let me point out that you can manually deploy these things too. In a case where I'm working with a standalone DNS server, I don't have AD integration, I don't have an easy way to be able to automate the creation of those trust points. I can import them from here. When I import one of these from here, I'm choosing what location to import the file from. We're looking for the data that contains the DNS key information. That'll be coming in from some shared folder. I can go browse the network and go find the particular shared folder that's relevant. Neat. It's good stuff. All right, that's pretty much zone signing. One other element to this DNSSEC functionality that we haven't looked at yet is how to explain to our client computers that they need to take advantage of these settings. By default, Windows 7 and Windows 8 are what are referred to as non-validating clients. In other words, they do not deliberately check DNSSEC data unless they're specifically told to. That configuration can be done in the local registry of each machine. I wouldn't recommend that, of course. That's tedious and time-consuming and error-prone. The better way is, perhaps unsurprisingly, group policy. Those of you who have a Active Directory background know exactly what I'm talking about. Let me illustrate that. Let me jump to my Group Policy Management console, and we'll illustrate that concept. So here's the GPMC, Group Policy Management console. Inside of it, I want to be able to deploy some configuration settings to a particular set of particularly secure client machines. So let me build a quick organizational unit for that purpose. One really nice feature of the Group Policy Management console is you can build OUs on the fly. You don't have to jump to Active Directory Users Computers or to the Active Directory Administrative Center to make those changes. Anyway, so we've got a secure client OU. And I want to insist that any computer that's in this OU must use DNSSEC for all of its work. Or maybe all of its work relative to a specific portion of DNS. When it tries to resolve a particular set of names, I'm going to insist that it does DNSSEC validation on what it gets. How do I do that? I'm going to build a GPO We're going to make this my name resolution policy table settings GPO. I'm going to edit those settings. And we'll find our NRPT settings here. Computer configuration, policies, Windows settings. There it is. Name resolution policy. So name resolution policy is designed to be able to ensure that when we go to resolve particular names to IP addresses via DNS, that we do so in accordance with one of a number of interesting policies. We can apply those rules to some part of our DNS environment. We can apply it to DNS names that use a particular suffix, so something or other .local, something .globalmantics.local. I can do it with a prefix, hr dot something, hr.star, so anything in the HR division that way. I can target it at a specific fully qualified domain name, particular ranges of IP addresses. In this case, let me apply it to just anything in the globalmantics.local domain. For that, I can turn on a variety of policy rules. Now, some of those are not relevant to our work just here at the moment. I want to draw your attention to this first tab, in which we want to turn on DNSSEC rules. I want to insist that DNS clients check to make sure that any data that they get from their DNS server are valid. Now, interestingly, DNS servers are automatically validating sorts of tools. If a DNS server consults data from some other DNS server and gets a response back, if there is an opportunity to validate that data with DNSSEC, the DNS server will take advantage of that. Clients are different, though. Clients need to be told, please use DNSSEC. Otherwise, they will by default ignore it. They will happily use data even if it's not digitally secured by DNSSEC. My second option here is to insist that any communication with my DNS server not only is secured with DNSSEC security using the public-private keys to validate that data, but I also want to actually perform that work over IPsec, where I scramble all the communication packets between the client and the server to make sure that anybody who intercepts those packets traveling from client to server sees nothing but digital confetti inside of those packets. It's a neat trick. All right, so that is the creation of a DNSSEC rule. Once I've created it, here's one of the hardest parts of NRPT in my mind, is that there's part of the GUI down below here that you would never know is there if you weren't looking for it. I can go ahead and create that rule, and it becomes part of my rule list here in my NRPT. That's the hard part. The rest of it, that's easy. Having done that, I can apply those settings, and we're good. I've configured that setting inside of my GPO. My GPO now knows about those rules. I can successfully close it up, and I'm in business. So we've seen how to configure a name resolution policy table as the logical completion of our process of enabling DNSSEC. All that with the idea in mind of making sure that we can trust the data coming from our vitally important DNS servers. Thanks for being a part of this lesson. I look forward to delivering the next one to you.